Today I shall discuss the mass flow rate, the mass flow rate of steam through the turbine, which is denoted by m dot s. We have to find this value m dot s. Okay. Now first of all we have to draw the turbine. We know the turbine present on the drum, on a drum. This is a drum upon which the turbine blades are arranged like that. These are the blades on the drum. This is the drum, and this is the ring. This is the ring upon which this is this blade tips are arranged, okay, at the ring. So the mass of steam that can flow through this area, only this area is available to transfer the mass of the steam, and no mass of steam or steam can pass through this drum diameter. This is the drum diameter. This is drum, okay. This is denoted by small d. So small d is the drum diameter, okay. Now what is this? This is the height of the blade. This is h, height of the blade height is capital H. H is the height of the blade, okay. Now first of all we have to find this area through which the steam can pass. So before that you have to develop this area. First of all, for the developing, we know the periphery into this height is the area. Periphery, this one or this one. The periphery into this height, that is the total distance of this into this, or total distance of this into this distance, that is h, is the area. But we don't know what area should be taken, what periphery should be taken, this periphery or this periphery. So for this case, if we take at the middle the line which produce the periphery at the center, now this periphery is the pi diameter of this. So if this diameter is d mean, that is d mean, then if we make the multiplication with pi, then this will be the periphery along this line. This periphery is pi d mean, okay. Now if we developed, then we can find this area is a, which is this distance is pi d mean, and this distance is the height of the blade, that is h, So we can write pi d mean into h. This the area, which is this area. I have taken this periphery, which is this one, that is pi d mean is the length of this line. Okay, I have not taken this periphery, that is the distance of this line, not distance of this line. I have taken the middle of this, so this pi d mean is this one. Okay, now this what is this? This area is the area of the turbine through which the steam can flow, which is A. And this A equals to, we have already have obtained pi d mean into h, this area. Now what is pi d mean? The relation between d mean with small d, we can obtain, you can see the d mean, that is this distance, equals to small d plus this distance, small d, this distance is a small d, and plus this distance plus this distance. What is this? This distance is h by 2 plus h by 2, because this distance is the h by 2 and this distance is h by 2, because this total distance is h, so this distance is h by 2 and this distance is h by 2. Okay, now this h already present, you can write pi d plus h into this h. Okay, now we know the velocity of steam through this direction of turbine is flow velocity. That is Vf, flow velocity. Only this flow velocity is available to transfer the mass of steam through this area. So we can write the volume of steam that can pass through the turbine is the volume, that is V, which is this area A into this V suffix F, because area into velocity is the volume, so this volume is obtained, this is the volume. Now put this value of A, we know the value of A is pi d plus h into h, that is pi d plus h into h into V suffix F. That is the volume of steam which can pass through this turbine. Now we know the specific volume of steam equals to volume of steam divided by mass of steam. Everybody know the specific volume of the steam equals to the volume of steam by mass of them, that is the volume by mass. Now this equals to, we know the volume of steam is V and mass of steam is m dot s. Mass flow through this turbine is m dot s. So this is for dry steam. For dry steam, this m dot s is obtained. But if this is not dry steam, then what you can write? V by m dot s into dryness fraction x, that is for wet steam. For wet steam. Now what is this? This is dryness fraction. Okay. Now if we take this m dot s, we obtain V, and the specific volume of the steam is denoted by V suffix s. Okay, V suffix s. Then we can write this V suffix s into x. Okay. Now I have taken the V suffix s into this direction and m is in this direction. So m dot s equals to, you can write V, we have obtained this value pi d plus h into V suffix f. So we can write pi d plus h into h V suffix f divided by small V suffix s into x. Okay, this is specific volume of the steam, and this is dryness fraction, this is the height of the blade, this is the drum diameter, this is the flow velocity of the steam. You can obtain this mass flow rate of steam through this turbine.